So what is a compound inequality? Think about this situation. At many restaurants, kids 12 and under, or senior citizens 55 and older, eat for free. What would the graph above look like if you marked all the ages of people eligible for the discount? Is this what you imagined the graph would look like? How about this next situation? Going to the doctor and having your blood pressure taken. What's considered a good systolic pressure? Is this what you imagined the graph would look like? Let's take a look at the following compound inequality. 5v plus 3 is less than negative 7, or negative 2v plus 7 is less than 1. So what we're looking for is any value for v, in fact all values for v, that would make either the first inequality over here or the second inequality true. So what we basically do is we solve them like any other inequality, just one at a time. So over here I would first take away the plus 3 by subtracting 3. I get 5v is less than negative 10. Divide by 5. And I would get v is less than negative 2. So v can be any number less than negative 2. Or, now I do the other one. Negative 2v plus 7 is less than 1. So minus 7 from both sides. We get negative 2v is less than negative 6. Divide by negative 2. And don't forget about this from earlier lessons. When we divide by a negative, we got to flip the inequality symbol. So here we get v is greater than positive 3. Okay, so our values for v can fit into either the first category or the second category. So now let's take a look at what the graph looks like. We make our graph line, our number line, and I first mark any values for v less than negative 2. But no equal sign, so not including negative 2. So I want to start at negative 2 but not include it, so an open circle, anything less than that. Or v can be any value greater than 3. Again, not including 3 because there's no equal sign, so another open dot and an arrow to the right. Alright, and so that's the graph for the compound inequality. It gives us all values that are less than negative 2 or values that are greater than 3. So let's take a look at this next compound inequality. Negative 4 is less than r minus 5, which is less than or equal to negative 1. So basically what they've done here, and you'll see this quite often, is they've basically jammed two inequality problems together. And what you first have to do is think about them separately. And the way we do that is basically we're going to reuse this middle portion here. And I'm just going to box it out so we can see it. Okay, this part we're going to reuse twice. So basically our first inequality is this part. Negative 4 is less than r minus 5. And at the same time, anytime they're jammed together like this, it's an and statement. And now we underline this other part. We reuse the middle part that I've boxed out. R minus 5 is less than or equal to negative 1. And now I've got our two separate inequalities which we can solve. So over here, add 5 to both sides. We get 1 is less than r, which, as we know in previous lessons, it's a little hard to read, so I'm just going to reverse it. R is greater than 1. And at the same time, over here, if we add 5 to both sides, our values for r also have to be less than or equal to 4. So we need to graph all the values for r that satisfy this inequality here. R has to be greater than 1, and at the same time less than or equal to 4. So let's think about what a graph looks like for an AND statement. Well, if it was just this one, r is greater than 1, we'd have an open dot at 1, and we'd have an arrow going off to the right, everything greater than it. But this compound inequality says, and r has to be less than or equal to 4, which means that I can't go above 4 here. And since it's equal to 4, a closed dot. So basically the only ones that satisfy this inequality and this one at the same time are all the numbers in between. So this is what our graph would look like. Basically no arrow. R is greater than 1, and r is less than or equal to 4. And so we get this line between the two dots.